Are you struggling with chemical equations? Feeling a little lost in all those letters and numbers? Well, don't worry. In the next few minutes, we are going to crack the code on this and turn this tricky topic into something you can absolutely master for your exams. Ready to jump in? Here's our game plan. First, we'll get the basics down. Then we'll master the single most important skill, tackle some real exam-style problems, and wrap it all up with some insider tips and a quick quiz to make sure it all sticks. Let's do this. All right, let's start at the very beginning. What is a chemical equation? Before we get into the textbook definition, I want you to think of it like a recipe. It's the language chemists use to tell a story about how things change from one substance into another. It's kind of like the secret language of molecules. You've probably seen this yourself, right? That amazing shine on a new wall? That's pure chemistry happening right in front of your eyes. The wet stuff on the wall is basically having a conversation with the air. And a chemical equation? That's just how we write down that conversation. It's actually super simple. On the left, you've got your ingredients. We call those reactants. On the right, you've got what you end up with, the products. And that arrow in the middle? That just shows the change, the transformation. That's it. So now that we know the basic layout, let's get to the part that really matters for your exams, balancing the equation. I know, this is where a lot of people get tripped up, but I promise, there's a simple rule that makes it all just click. And here it is. This is our golden rule. It's called the law of conservation of mass. All it means is that you can't just create or destroy atoms out of thin air. Think of it like Legos. You can take apart a car and build a house, but you're still going to have the exact same number of bricks you started with. Atoms work the same way. Okay, let's put that to the test. Look at this reaction. If we do a quick head count on the left side, the LHS, we've got 1 zinc, 1 hydrogen, and 1 chlorine. Simple enough. But look at the right side. We've suddenly got 2 hydrogens and 2 chlorines. Wait a minute, where did they come from? This breaks our golden rule. This equation is unbalanced. So how do we fix this? We use something called the hit and trial method. It sounds fancy, but it just means we're going to nudge the numbers around until it all adds up. The most important thing to remember is step 3. You can only add big numbers, coefficients, in front. You can never, ever change those little subscript numbers. So to fix our problem, we just put a big 2 in front of the HCl on the left. And that's it. Now let's do our head count again. 1 zinc on both sides, check. 2 hydrogens on both sides, check. And 2 chlorines on both sides, check. Perfect. The scales are balanced and our golden rule is happy. Okay, great. So we can balance an equation, but why? What's the point? Well, this is where it gets really powerful. Once an equation is balanced, it's not just a description anymore. It's a precise recipe. And that recipe lets us calculate exactly how much stuff we need. This skill has a fancy name, stoichiometry, and it's a huge deal for your exams. So here's a classic exam question. I know it looks a little scary, but trust me, our balanced equation holds the key to solving it. And this isn't just a random problem. This reaction is actually used for some pretty cool stuff in the real world. This is where the magic happens. The balanced equation gives us the secret ratio. See those big 2s in front of the aluminum and the iron? They tell us that for every 54 grams of aluminum we use, we are guaranteed to get exactly 112 grams of iron. It's a fixed chemical promise. And once we have that fixed ratio, the math becomes pretty simple. If we want 1,120 kilograms of iron, a quick calculation shows us we need exactly 540 kilograms of aluminum. See how powerful that is? Our balanced equation just let us predict the exact amount needed for a massive industrial process. But, what happens if you run out of one of your ingredients? Well, that's called your limiting reagent. It's the reactant that gets used at first, and it basically shuts down the whole reaction. It limits exactly how much product you can possibly make. All right, let's wrap up the theory part with some practical tips to help you crush your exams, and then we'll look at where these equations show up in the world all around us. Want to balance equations like a total pro? Here are a few shortcuts. Always start with the metals. Leave the easy stuff like hydrogen and oxygen for the very end. And here's a great one. If you see a group of atoms like SO4 that stays together on both sides, just treat it like one single thing. And of course, always do a final check. So why does all this matter? Well, chemical equations are describing things happening all around you. That thermite reaction we just calculated, it gets so hot it's used to weld massive railway tracks together. An airbag in a car, that's a super fast chemical reaction. Even baking a cake, the reason it gets all light and fluffy is because of the gas produced in a chemical reaction. Phew, we have covered a ton of ground. So let's lock in everything we've learned with a super quick summary, and then it's time to put your new skills to the test with a rapid-fire quiz. You ready? If you only remember 3 things from all of this, make it these 3. 1. Equations are the language of chemistry. 2. They absolutely must be balanced. And 3. A balanced equation is your recipe for doing all sorts of cool calculations. Okay, you ready to test yourself? This is honestly the best way to make sure you've really got this stuff down. Here we go. Okay, here are the first 5 questions. Go ahead and hit pause, think about them, and then press play when you're ready. All right, you back? Let's see how you did. The answers are reactants, the law of conservation of mass, the coefficient is 2, you get 2 moles of water, and number 5 is stoichiometry. All right, time for the last 5. Hit pause again and give it your best shot. Okay, let's go over the answers. The products are barium sulfate and sodium chloride. The limiting reagent is oxygen. The little just means it's a solid. The thermite reaction is for welding railway tracks. And for the last one, you can't change the subscripts because that would change the actual molecule. You'd be talking about a completely different substance. So, what's the big takeaway from all this? You now know how to read and write in the language of chemistry. Remember, an equation isn't just a boring formula. It's a dynamic story of transformation. So keep practicing, stay curious, and you'll be amazed at the stories you can start to uncover.